On-demand bandwidth provisioning and flow handling is another important use case for data centers. In order to support applications for their customers and maintain SLA, the data centers need to scale up and down their network according to the demand of bandwidth. Policy of over-provisioning of bandwidth for rainy days increases cost and reduces efficiency. To handle real-time demand of bandwidth, the network needs to have programmability, flexibility, and single management layer. A data center needs to support the variety of dynamic workloads generated by their enterprise customers as well as internal reserved workloads. The network design should take care of handling different packet size and different rates, ensure interplay between workloads does not hamper the high priority reserved workload, handling microbursts, and last but not the least, minimizing the latency for mission critical workload. The SDN controller can receive requests for service attribute modification from application layer either on demand or scheduled for future. OpenFlow is used as a southbound protocol to insert or modify flows into the OpenFlow enabled switches to change attribute of data traffic flow. OpenFlow is also used by the controller to monitor the data traffic through the fabric through southbound APIs. Optimizing the throughput in a data center requires load balancing not only based on path cost but also on the size of the flows. OpenFlow based equal cost multipath is a popular routing mechanism to achieve load balancing in software defined data center networks. OpenFlow controller can pull statistics from each flow independently and help in identification of elephant and mice flows. The task of a network engineer of an OpenFlow based data center is not easy. Evolving standards and challenges due to unknown performance numbers makes validation an absolute critical element of network design, starting from the vendor selection phase to the final deployment phase. The OpenFlow controller needs to support the scale of the data center traffic. The latency in response by the controller can become a bottleneck in overall performance of the data center. Therefore, it is extremely important to validate the controller performance by emulating huge east-west traffic through the OpenFlow switches. On the other hand, OpenFlow-based forwarding devices needs to support a large number of flow entries. A badly designed switch will lose its forwarding performance at a stressed condition with large number of flows installed. During the vendor selection process, the network engineer needs to stress the switching hardware from every angle. Please watch our product demo videos to learn more about OpenFlow validation using IX network.